of page 368. From last video to this one, interruption of the school day, that's all right. We have highlighted in the diagram, KM is 80 degrees. We should also probably put 80 degrees on the outside edge of the circle. And then LN, that arc is 30 degrees, so I'm going to put a 30 degree here. This is setting us up for success on the next couple of parts to this question too. And in our work here, we're going to be thinking about like the interior angles, the intercepted arc, right? Our vocab word up here. The inscribed angle creates an intercepted arc. And that intercepted arc and the inscribed angle, there's a 1-to-2 relationship. That's what we're exploring. Okay, from part B, where we left off, it says, when you draw chord KN, can you then determine the measure of angle KPM with the information that's provided? And honestly, not really, right? There's just not enough detail for us to do yet. We're almost ready to do this, or we need to be thinking about our information. Part C, use the information given in the figure to name the measures of any angles that you do know. And I know this. I know that, let me zoom in over here on our shape, okay? If we have an 80-degree angle, right? We have an 80-degree intercepted arc, then the inscribed angle is going to be 40 degrees. And that inscribed angle is angle KNM. So put a marker for an angle right there and make sure that you mark it as 40, half of the 80 that's on the outside. It would also be a wise idea to actually write that down in part C. So I won't show it on the video, but it's on my page right now, and I'll zoom out so you can see it. I'm going to say angle measure of angle KNM is 40 degrees because it's half of 80. That same logic from the 30 degrees and this inscribed angle over here tells us that angle LKN, put a marker, is half of 30. Label that as 15. You got a 15 degree right there. I'm going to write that down, right? I'm going to measure of angle LKN is 15 degrees. It really does look an awful lot like we have a triangle with some information that's known. In fact, this is further information that I can identify. Big brain moments. If I have 40 right here, then two things can automatically be found right now. One of the things that can be found is that this angle on the other side, and I don't want the 30 to be considered part of it, all right? I don't want the 30. I want the 30 to be the green arc measurement. But this angle that is KNP, this angle N is 140 degrees. Why would that be possible? Why would it be true that this angle is 140? Pause, think about it. Did you come up with the fact that 40 degrees here and 140, those two angles form a linear pair, so they have to add to 180 degrees? That's what's happening. I can now go down to part C, and I can continue writing down angle measures that I know. I know that the measure of angle KNP, that pink angle, is 140 degrees. Now, finally, in the shape that we're given, the goal really is to find a measurement for angle P. It's an exterior angle to the shape, right? Is it 40? Is it less than 40? Like, what's the relationship? How big of an angle is angle P? It might be like the subtractive difference of 80 minus 30 divided by 2. Something like that might be what's happening. I do have a compass. If these are actually 80 and 30 degrees, I could just measure it, but we'll maybe save that for a minute. Check out the triangle that we have. What do you know about the fact of all of the angles of a triangle? Again, 30 is not a part of the triangle. 30 is the arc LN, so 30 is not in the triangle. But if you go 140 degrees at angle N, 15 degrees at angle K, then the remainder, 25 degrees, should be at angle P. And I know that because the angles in a triangle add to 180. Or I also know that because 40 is an exterior angle to the triangle KNP. So two angles away from the 40-degree angle, they're called the remote interior, should add up to 40. 30 is not one of that. So it's 15 and some number has to add to 40. That means that angle P is 25. The measure of angle KPN is 25 degrees. Let me share with you what I wrote down, okay? All of that. All of what's here. Okay, next question then says, how does angle KPN relate to triangle KPN? And it's honestly, it's an interior angle of our triangle. We have some further information. I wrote those down too. I think I'm kind of actually skipping what the book is saying. There's probably some more stuff here that we should be acknowledging. So let's just kind of breeze into it. KPN, angle KPN is in the interior of triangle KPN. Write a statement to show the relationship between the measure of angle KPN and the measure of angle NKP and the measure of angle KNM. That's a lot of letters. Let me go see if I can figure that. I'm going to highlight KPN green, and I'm going to go find it in the diagram and highlight it green. I'm going to highlight NKP pink. I'm going to go find that in the diagram and highlight it pink. I'm going to find angle KNM and highlight it orange. And then I just want to like observe what sort of relationships we get from those. Okay, so let's go find KPN. KPN is going to be highlighted, I even put a circle around it, it's going to be highlighted green. NKP is going to be highlighted pink. NKP. So this angle. And then last of all, orange, KNM. KNM is this one. Oh, okay. So green and pink are the remote interior angles that I was talking about, which means when you add their numbers together, they equal the exterior angle of the circle, or the triangle. So that's what I'm going to write down for part E. I'll bring in some highlights, and I want to acknowledge orange is the exterior angle. So maybe put a little exterior here. Exterior. And these two are the remote interior angles, of course. So writing our statements. The measure of angle KPN plus the measure of angle NKP equals the measure of angle KNM. This is the exterior angles theorem for a triangle. Therefore, what's the measure of angle KPN? 25. I already found it. Bring that one down. The measure of angle KPN equals 25 degrees. All right, this is where it all comes together with what we need to know. Describe the measure of angle KPM. Oh, okay, they just wanted to extend it out from N. Keep drawing on the line to N to M, okay? So the measure of KPM is the same as KPN. And we want to describe it in terms of the arcs that are intersected by that angle. And I had a hunch, and I went with the hunch. On the inside, you add the arcs and divide by 2. But P creates an angle outside the circle, so we're going to subtract the arcs and divide by 2. Subtract the arcs and divide by 2, which is what happened, right? We took 80 minus 30, and then divide by 2. 50 divided by 2, 25. It turns out it was actually a 25-degree angle. But bam, what? Okay, there it is. There is more to follow on page 369. Please make sure that you are flipping through, following that one. We've got to get to a proof. The proof of the exterior angles of a circle. Thank you for watching this part of this video. Keep going in the sequence. We'll see you in the next video.